press the bell icon on the YouTube app and never miss another update.
Hello students, I hope you all are fine. And in the previous video I had showed you the geometrical method to find out the zero of the polynomial. And now I am going to show the relationship between the zeros and the coefficient of a polynomial. Along with that, we will just see how to find out the zero by using algebraic method also. So let us consider a simple linear polynomial 2x plus 3. Now you all know the general form of this p of x is equal to ax plus b. This is the general form of the linear polynomial. Now p of x is equal to 2x plus 3. Now to get the zero of the polynomial, in the previous video I had showed you. So you will put 0 here, p of x will be 0, 2x plus 3. Now 2x is equal to plus 3, we will move to the other side, that is minus 3. So x is equal to minus 3 by 2. So this is the zero of the polynomial, that is x is equal to minus 3 by 2. Now just compare this with the general form here. See, this is the general form of an polynomial, that is of linear polynomial. Now just compare this with the this general form. Now can I write this minus 3 as minus is there b, that is 3. See this you compare. So a is what? A is 2 and b is 3 here. Now minus b 2 is a. So minus b by a. So easily we can say that the linear, how to find out the linear zero of the polynomial, p of x is equal to ax plus b. So to find out the zero, we are going to use minus b by a. So here minus b by a. Now here see the concept here, relationship between the zeros and the coefficient. I hope you all know what is the meaning of this coefficient. See this x is a variable and 2 is the numerical coefficient of x and 3 is a constant. So numerical coefficient. Now we will compare this with the coefficient. Now b minus b means here minus b. B is what here? Constant. B is a constant divided by a. A is nothing but the coefficient of x. Coefficient of x. So this is the general form of finding the zero of the polynomial of a linear polynomial. See once again I will tell you, p of x, the general form of linear polynomial is ax plus b, means minus b by a. Minus b is what? That is the constant term divided by coefficient of x. So like this we can find out the zeros of the polynomial. One more example I will give you, 7x minus 3. P of x is equal to 7x minus 3. Now once again I will put 0 here to get the zero of the polynomial, 7x minus 3. Now 7x is equal to, 7x will be there only, then minus 3 you are transposing to the other side, it will become 3. So x is equal to 3 by 7. X is equal to 3 by 7 is the zero of the polynomial. Just now I told you it is nothing but minus b by a. So minus b by a. Now just compare this with the coefficient here. Now here minus b by a. Now we will see. Now just compare this with the linear general form of linear polynomial, ax plus b. No, minus of, see this is minus, so b is nothing but minus 3. Now a is 7. So this will become minus into minus, this will become 3. 3 by 7. See 3 by 7. See here x is equal to 3 by 7. Yes, then we can come to the conclusion that here 3 by 7 is nothing but the 0 of the polynomial. We are comparing with the coefficient of the linear polynomial, minus b by a, minus b by a. So this is how you can compare the relationship between the zeros and the coefficient of the polynomial, So now we'll see for the quadratic polynomial how we can do for the quadratic. So in the general form, so ax plus b is the linear polynomial, and to get the 0 of the polynomial directly we can write minus b by a. Minus b is nothing but minus constant term divided by coefficient of x. Now we will move on to the quadratic polynomial. I will just take one example from your textbook, NCERT textbook only. Now I will take the example which is given in your textbook to find out the quadratic zeros of the quadratic polynomial. P of x is equal to 2x square minus 8x plus 6. 2x square minus 8x plus 6. Now here you know you have learnt in 9th standard splitting the middle term. So when you split the middle term you will multiply this, 6 2s are 12. So when you split this you will you need to get minus 8. So here plus 12, minus 8 means minus 6 minus 2, minus 6 minus 2 will give minus 8. 6 2s are 12, minus into minus plus. I hope you can recall this method, that is splitting the middle term. Now when you split the middle term, 2x square here minus 6x minus 2x plus 6. Now here 2x is common. If you take 2x common, here x remains minus 3 and here minus 2x minus 3. See once again, 2 into x minus 2 into x minus 2x minus into minus plus 2 3s are 6. Now if you equate, now what is common here? X minus 3 and 2x minus 2. X minus 3, 2x minus 2. Now x minus, see to find out the 0, x minus 3 should be equal to 0. So x will be equal to 3. Then here 2x minus 2 is equal to 0. So 2x is equal to 2. X is equal to 2 by 2, it is 1. So x is equal to 1 and x is equal to 3. They are the zeros of the quadratic polynomial 2x square minus 8x plus 6. So I will write, therefore the two zeros of the polynomial, are, one is 3 and the other one is 1, 3 comma 1. Now this is the one part of the problem. Now you have to compare this, that is our basic concept is relationship between the zeros and the coefficient of the polynomial. Now to compare it with the polynomial, to compare it with the coefficient of a polynomial, let us take this as alpha. Let the two zeros be alpha and beta. Let it be alpha and beta. Let alpha and beta are the zeros of the polynomial. Now, sum of the zeros. Let us find out the sum of the zeros. So, when you want to find out the sum of the zero, that is alpha plus beta. So, alpha plus beta will give you 3 plus 1. See, I hope you understood. So, this is alpha, 3 is alpha and 1 is beta. Means general form you will take let alpha and beta are the zeros of the polynomial. So, sum of the zeros means alpha plus beta. Alpha plus beta will be 3 plus 1. 3 plus 1 is equal to 4. Now, to compare this with the coefficient, you all know the general form of quadratic equation is ax square plus bx plus c. P of x is equal to ax square plus bx plus c. Now I got this 4. Means now here minus b by a. So minus b by a means here, now compare this with the polynomial here. So what is a? A is 2, b is minus 8 and c is 6. So I am comparing that coefficient. A is 2 and b is minus 8 and c is 6. Now if you do minus b by a, minus of b is minus 8. See, this minus is of this and b is minus 8 divided by a is 2. So minus into minus plus 8 by 2 is nothing but 4. See, you got the sum as 4 and like this you have to compare. So what is minus b by a now in the quadratic polynomial? What is minus b by a? So when you compare this with the general form, so minus of, now here in this case b is nothing but the coefficient of x. So can I write here coefficient of x divided by a is nothing but the coefficient of x square. Coefficient of x square. See, minus b by a. So for quadratic polynomial, minus of coefficient of x divided by coefficient of x square, that is 2 here, in this case 2. Coefficient of x square is a means here 2, see, like this. So this is the method you have to find out, and also you have to compare that with the coefficient. Now let us move on to the, now this is the sum of the zero. Now let us find out the product of the zeros. Now product of the zero. Now alpha into beta. So what is the product of the zero? Product of the zero. So zeros are 3 into 1. 3 into 1 is 3. Now I am going to compare with this c by a. What is c by a? Now c is, our question was, the question was 2x square minus 8, 2x square minus 8x plus 6. Now c is what? C is 6 by a is 2. 6 by 8, 2 is 3. See, alpha, that is product of the zeros also 3, c by a is 3. Now, how to compare? Means here C by A is nothing but C. C is what in the general form? C is the constant term. Constant term divided by A. A is what? Coefficient of x square. Coefficient of x square. Like this. See, I have finished. First, I found out the zeros of the polynomial. Next, alpha and beta are the zeros. So, I got the sum of the zeros. Then, I am comparing that with the coefficient of the general form, that is here ax square plus bx plus c. That is, sum of the zero is minus of coefficient of x divided by coefficient of x square. Product of the zero, then c by a. C by a is equal to constant term divided by coefficient of x square. So, this is how you have to find out the zeros of the polynomial, and also you have to compare that with the coefficient of polynomials. So, next, yes, now I'll do the example 2 from your textbook, page number 30. See, the question will be like this. Find the zeros of the quadratic polynomial. Find the zeros of the quadratic polynomial x square plus 7x plus 10. So, you have to find out the zeros of the polynomial of quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficient. You have to verify the relationship between the zeros and the coefficient. First you have to find out the zeros, and the next you have to compare it with the coefficients of the quadratic polynomial. So, what is the first step now? Just now I told you. So, let us take x square plus 7x plus 10. Now, splitting the middle term. So, factorize it by splitting the middle term. Here 10. So, 10. So, when you split it into 5 2s are. So, 5 plus 2, again you will get 7. Since it is positive, you can put plus sign. So, x square plus, how to split this? Plus 5x plus 2x plus 10. Now, what is common here? Here x is common. So, x plus 5. And here 2 is common, x plus 5. Now, x plus 5 into x plus 2. So, this is how you have to split the middle term. Now, to find out the 0, I told you x plus 5 is equal to 0. So, x is equal to minus 5. Same way here, x plus 2 is equal to 0, x is equal to minus 2. Now, just see here, x is equal to minus 5 and x is equal to minus 2 are the zeros of the polynomial of the x square plus 7x plus 10. Now these are the zeros. Now you have to find out the sum of the zeros. So I told you in the previous sum, alpha and beta, if you take alpha and beta, alpha plus beta is equal to minus 5 plus minus 2. I hope you understood. See, minus 5, minus 2 are the zeros of the polynomial. So alpha is minus 5 and beta is minus 2. You are going to add. Means this will become minus 5 minus 2, you will get minus 7. Now, how to compare it with the coefficient? See, just now I told you alpha plus beta means minus b by a. You find out minus b by a according to this. So, minus b is which one? Minus b, this is b term. So, when you compare this with the general form ax square plus bx plus c. So, you compare a is 1, numerical coefficient here it is 1 and b is 7 and c is 10. Now, minus b means here minus 7 divided by a is nothing but 1. See, minus 7 by 1, it is nothing but minus 7. See, minus 7, minus 7. Yes. So, we can write this as minus b is what? Minus b is minus of coefficient of x divided by 1. 1 is nothing but coefficient of x square. So, this is how you have to do. Now, after doing the sum of the 0, just find out the product of the 0. Alpha beta is minus 5 into minus 2. Minus 5 into minus 2 is minus into minus plus 10. Now, c by a, when you want to compare c by a, now you compare with the coefficient. See here 10 by a is 1. So, here see 10 by 1 is nothing but 10. So, you can compare like this with the coefficient. So, this is how you can write 10 as constant term divided by 1 is here 10 by 1. 1 is nothing but the coefficient of x square. Like this you can verify and you can find out by verifying the coefficient of the polynomial. Now the next example 3. Example 3. Find the 0 of the polynomial. Again a quadratic polynomial they have given, but a little bit a different problem, that is x square minus 3. So in the previous classes, like in the lower classes, you have studied this x square minus 3, how to factorize it and verify the relationship between the zeros of the coefficients. Okay, now third example, the polynomial they have given it as x cube, p of x is equal to x cube minus 3, x cube minus, sorry, x square minus 3, x square minus 3. Now how to find out the how to do the factorization here? See, this can be written as x square minus root 3 whole square. See, in the lower classes you have done this type of polynomial, splitting, not splitting the midterm, this is to factorize x square minus 3. See, x square minus root 3 whole square. When you write root 3 whole square, root 3 into root 3, root 9. Root 9 means nothing but it is 3. So now can you tell me it is in which form identities you have learnt in the lower classes? That is, it is in the form of a square minus b square. A square minus b square means a plus b into a minus b. So this can be written as x plus root 3 into x minus root 3. X plus root 3, x minus root 3. Now to find out the 0, I told you x plus root 3 is equal to 0. Means x is equal to minus root 3. And here x is equal to x minus root 3 is equal to 0. So x is equal to root 3. So minus root 3 and root 3 are the zeros of this polynomial. Now sum of the 0. Let alpha and beta be the zeros of the polynomial. Sum of the 0. So minus root 3 plus root 3. So minus root 3 plus root 3, it gets cancelled and you will get 0. So here if you take, just compare this with the general form. When you compare this with the general form is ax square plus bx plus c. Now the general form here, a is equal to 1. See, just compare, a is equal to 1. But here, see, this term bx, x variable only is not there here. So here b is equal to 0. Again c we have, that is minus 3. Now 0, see, definitely we can write it as b. So if you write minus b by a means 0 by 1 is nothing but 0. See, minus b by a is the coefficient of x divided by coefficient of x square. See, 0 by 1 means that is 0. Now this product of the 0, alpha beta is equal to minus root 3 into root 3. So root 3 into plus into minus, root 3 into root 3 is root 9, root 9 means 3. So minus 3. So this minus 3, so also we can write it as minus 3 by 1. See here minus 3, just see, it is nothing but c by a. So c by a, c is what again? Constant term divided by a is nothing but coefficient of x square, Now you verified, means you compared the zeros of the polynomial to the coefficient of a polynomial. Yes. So like this you have to find out the 0 first step, you have to find out the 0, and the next you have to compare with the coefficient of a polynomial. So this is the method. Now one more example is there in your textbook, that is find a quadratic polynomial. See, now vice versa. See here actually they had given the polynomial and you found out the zeros of the polynomial. But in this question, example 4, that is page number 31, find a quadratic polynomial, the sum and the product of whose zeros are minus 3 and 2 respectively. Means here they have given the sum and also the product of the zeros. That is, sum is minus 3 and the product is 2. Product of the 0 is 2. You have to frame a quadratic polynomial. So this is a different type of question. Now I'll just show how to do this. Now find a quadratic polynomial. No? The sum is minus 3. Sum is minus 3 and the product is 2. They have given. So here we all know alpha plus beta. The sum is minus 3 and the product alpha beta is 2. If we take alpha and beta are the zeros of the polynomial, then sum they have given, sum is minus 3 and product is 2. Now how to find out how to frame the polynomial? Now since there are two zeros, then it is a quadratic polynomial. Now actually we have one formula, but they are not given in your textbook. Please observe carefully. See, x square minus alpha plus beta into x plus alpha beta. See, this is how you can frame the quadratic polynomial. See, x square minus alpha plus beta. Alpha plus beta means the sum of the 0. Alpha beta is the product of the 0. So we can directly write the answer. See how to write p of x is equal to x square minus, this is the sum of the 0. Sum of the 0 they have given it as minus 3 into x plus product of the 0, that is 2. So this quadratic polynomial will be minus into minus plus 3x plus 2. So this is how you have to find out, you have to find out the polynomial when the sum of the zeros and the product of the zeros are given. So in the next video, I'll just teach you how to work out the next exercise, that is 2.2. Thank you.